Assalamualaikum warahmatullahi wabarakatuh. My name is Aiman Danish and my metric number is AN240036. And I want to present about question 1. For question 1, we need to solve the initial value problem IVP using a homogeneous equation, mathematical software, and second order Taylor series method. And we also need to calculate the absolute error for this problem. Okay, for question 1, A1 Roman, the equation is dy over dx equal to x plus y over x. So we use the homogeneous equation and we get the answer is yx equal to x open bracket ln x plus 2 close bracket. For the question 1, A to Roman, we use the Google Colab website to for the mathematical software method, and this is the screenshot of recording, and we got the answer is yx equal to x open bracket log x plus 2 close bracket.
Assalamualaikum warahmatullahi wabarakatuh. My name is Hayati with metric number DN240163, and I will explain for our presentation for the previous question 1 for A3 Roman and question B. So in this question of 3 Roman, we must find the approximate value using the second order Taylor method, which is x equal to 1 multiplied by 0.2 multiplied by 2. So in this question, we can get the h is equal to 0.2 and x0 is equal to 1 while the y0 equal to 2. Then for this Taylor method, we might use the formula of yi plus 1. So we can get the first derivative of y prime and second derivative of y2 prime from the equation given in this question. So we can substitute the y prime into the y2 prime, and we can get the last formula to use for the integration of 0, 1, 2, 3, 4, and 5. So the screen show the example of calculation for integration equal to 0, and we can get the y1 equal to 2.620. And then for this calculation, we can also use for the next iteration. And the all approximate value, we can transfer it into the table so we can easy to use for the next step of calculation method. This table show the approximate value for each iteration from 0 to 5. Next, for equation B, we must calculate the exact value by using the equation of yx equal to x multiplied by ln x plus 2 from the IVP of homogeneous equation at part A1 Roman. So, for x equal to 1, we can substitute the value of x into the equation to get the value of z. So we can continue for our calculation for the other value of x. And then to calculate the absolute error, we must using the formula of error equal to exact value minus approximate value. So by that, we can get the all of error value for each iteration, and we can put it on the table. Thus, this table shows for the complete of approximate, exact, and error value for each iteration in this question 1. That's all from me. Thank you.
Assalamualaikum. My name is Husairie. So I will explain the question 2. So question 2 asks to solve the initial value problem using the separable equation, and then use any mathematical software. Then third one is use second Taylor series method, and B, exact solution for the IVP. So let's we go to the answer. So for the answer for the question A, 1 Roman, after we calculate using the separable equation, we got the answer as shown at this slide. In this slide show that I use the Google Colab to put the coding and get the same answer like the question A 1 Roman. So that the same answer for the A question A 2 Roman. For the question A 3 Roman, the question asks to use second Taylor series method to solve this equation. So after I calculate, this is the final answer for the question that we got.
So for question 2b, we will calculate absolute error based on the IVP on question 2a1 Roman. So the absolute error formula is modulus z solution minus Taylor approximation. So I calculate 5 of it, which is x equal to 0, x equal to 0.25, 0.50, 0.75, and 0.1.0. So after that, I calculate it in 6 decimal places. Also with the Taylor approximation, I recalculate it also in 6 decimal places. For x equal to 0, its absolute error is 0. For 0.25, it is 0.001132. 0.50 is 0.002153. 0.75, it is 0.003072. And lastly, for the 1.0 is 0.003897. Thank you.